Hey y'all, so we're going to go through this quick example. This is introducing us to the ideas of rotational mechanics and really rotational terminology. So we have a tire here. The diameter of my tire is 0.6 meters. Okay, so I'm going to just draw this out. This may help me a little bit later. So the full diameter is 0.60 meters. You take a 100 kilometer trip at a speed of 72 kilometers per hour. During this trip, what was your tire's angular speed? Now, I remember from class that angular speed is equal to the angular displacement over the time. So I'm going to need both of those things, right? So the first thing I'm going to do is I'm going to figure out how much time was I traveling, all right? So I have here my speed and the distance that I traveled. And so I can do that pretty easily because we know that speed equals distance over time. And so all I'm going to do is I'm going to put that 72 kilometers per hour in. And then I'm going to put in my distance, which was 100 kilometers. And then I'm going to put T for time. Now, you may say, well, don't you need to convert this to meters? No, they're both in kilometers. So this is kilometers over hours, and this is going to be kilometers as well. So the kilometers are the same, which means when I get time here, the time is going to be in kilometers per, so it's going to be hours. And so that's fine. And so I'm going to go ahead and multiply by T, which will give me 72T is equal to 100. And then I'm going to divide both sides by 72. Sorry, it is 100, not 1,000. So divide both sides by 72. 100 divided by 72. And you can see that right here on my calculator. 100 divided by 72. And I get 1.3888. So my time equals 1.38 repeating hours. Now that's the number of hours. I know when I do angular speed, chances are I want that to be, what we talked about in class is we did revolutions per second or radians per second or degrees per second. I'm going to go for radians just because that's the most common one, but I am going to need it in seconds. So I'm going to take my hours here. I'm going to convert that to seconds. Now I know that there's 60 minutes in an hour and then 60 seconds in a minute. So that's 3,600. So I'm just going to take that number I had before and multiply it by 3,600. And so I get a total of 5,000. So 3,600 because that is the number of seconds per hour. And so I end up getting that my time is 5,000 seconds. All right. So we've got 5,000 seconds. Now, in order to get the angular speed, I now need the angular displacement, which is how many times has the wheel rotated around, okay, in order to go 100 kilometers. Well, I can get the circumference of my wheel. I can find out the distance around the wheel once by doing 2 pi r. And so I go 2 times pi times the radius, which is only 0.3. And so I get a circumference of 2 times pi times 0.3. And I get a circumference of 3 over 5 pi. If you want that as an approximate answer, you can always get that, but I'm actually okay with that. So I'm going to go 3 over 5 pi is my circumference. From there, now that is the distance around my wheel one time. So the question is, how many times does the wheel need to go around in order to accomplish 100 kilometers? All right, now this 3 over 5 pi is in meters. And so I'm going to take that 100 kilometers, I'm going to turn that into meters. So my total distance is 100 times 1,000. So that's 100,000 meters is 100 kilometers. So if this is one trip, then I can take that 100,000. I'm going to divide by that 3 over 5 pi. And that's going to tell me how many times this can go into 100,000. So how many times does my wheel need to rotate around in order to get 100,000 meters or 100 kilometers? Okay, so all I'm going to do is I'm going to type in that 100,000, and then I'm going to divide by my previous answer. And so I get 5301, so 53051.5 6, and that's probably far enough. I mean, it's only 2 sig figs here. I've only got 1 sig fig there. I've got 2 sig figs there, so this is probably fine. All right, so that is the number of revolutions. All right, so now I know the circle has to turn that many times in that much time. So now I'm going to put that together to get my angular speed. The angular speed, remember, is the angular displacement, which I could use revolutions here. So 53051.6 revolutions for 5,000 seconds. So I take that, I divide by 5,000, and I get 10.61 revolutions per second. Now, if I want to put it in angular speed like radians, then I just say, well, I know that 1 revolution is 2 pi radians. And so if I take that and I multiply by 2 pi, then I can get 66.66666, or in other words, my angular speed is 60. I guess if I go 2 sig figs, I could go 1 because of that. If I assume that that's exact, then I'm just going to go 67 radians per second. So there you go. That's part A. Now part B asks, how many times did they revolve? Well, we already know that. We know that they revolved 53,051 times in that 100 kilometers. And so we've actually answered both A and B, and that is the answer. That's all. See you next time.